So it means that if someone is saying something, you need to try. If you cannot solve, then you need to let me know. If you don't let me know that you believe that you will study later on, or it's okay, you can solve, it's very easy. So things are not like that, okay? Otherwise, like you get all the scores 60 out of 60 in the class test one. So I know that where is the difficulty. So that's why I ask the students to solve. Some things you can study by yourself. My guidance should be enough. So in that case, I just left those things to you. Like you can solve it. And if you have any problem, let me know. Okay. So I'm very disappointed because I already mentioned that you need to submit at least. I know few students that who always submit the things. I know 60 students will not submit, but I have some good students who are very punctual, who always submit, who always knock me to check the things. Okay. So if I have 10 or 15 students, should be okay because all the students are not in the same level. But because no, I didn't get any one reply yet to solve the problems. Okay, so that's why like I'm a little bit worried. I don't know. So you don't want to follow my instructions, or and no one replied. Okay, even I cannot get the reply. Couldn't get the reply that maybe you have some problem or you cannot solve. You have class test. You have so many projects. Sir, we need time. At least I need these kinds of also answer from you. Anyway, so because I need to move forward, okay, so I cannot stay behind and then wait for like you will solve the problems and then I can move forward. It's not possible because you will also have the class test two very soon. So I need to finish the things. Also need to give the project because for project one I give a long time, but for project two probably you will get only 2 weeks or 1 week or maybe probably 2 weeks. So I need to. You also need to think about it. Okay. So the things are we don't. We have 3 more chapters left, and also how many weeks we have. So you have to think about that. And by this time, you also need to let me know that if you have any difficulties. I believe my lectures, that video that I already uploaded, is sufficient for anyone to understand the thing. But if you still believe that the lectures could improve, or for an example, because I try to clear the basic. Okay, so I try to clear the basics, and I also try to explain the thing as simple as that. Okay, so that's why I haven't gone through the all the derivations, the how the things are coming, but I just focus on the applications and try to explain each of the problems from the book that we all follow as a module. For class test one, the questions are a little bit different because the moderator is actually want to raise the standard high. So that's why the questions might seem difficult, but your question two and question three, you can see that most of you score well. Only for question one, you have the problem. So anyway, we have the difficulty levels. Okay, so sometimes it could be higher, it could be lower. So we balance it. But the basic thing is how to solve the problems. This one we can only clear the methods how to solve it. Okay. Then the applications are so many types of applications. I always ask the students to follow the exercises in the module. Okay, so that at least you can have the idea that what kind of problem you can face um, in the exam or in the class test. Also, in the project, I also try to twist few things. When you want to solve that, you will see that the problems are not straightforward. Okay, so little bit tricky, and but not that much impossible and not much very difficult. But you need to think wisely. Anyway, so even for the project one, if few students already knock me, they have some problems. I try to answer it whenever I see the message. Okay, I always prompt. I never keep you waiting for that. I believe that you have so many subjects to also to study, so I don't want you to waste time on my course. Okay, so it should be straightforward. So anything you want to ask? I want to ask, like, is there any problem with the numerical integration, especially the Gauss quadrature method? Um, any problem? Have you tried to solve that problem? If you haven't tried, please try to solve it by today because I will carry on the forward. Okay, I will go to the ODE, ordinary differential equation today, and you will have the class test on numerical integration this Thursday. Okay. You want to ask anything before the quiz, because before quiz there is no way to meet with you. So you want to ask anything, you have any problems, or you haven't watched the videos. I can also trace that who are watching the videos, who are following the lectures. But again, I'm saying that I just believe on you, because is now you're adult enough, and it's very very difficult. Like if you want to cheat, you can cheat, because you can just click the things, and you actually, it will show that you already watch, but you are not in front of the monitor. So we can imagine lots of things. Okay, so that's why I don't believe on that tracking on monitoring. I just ask the students directly, try to connect with them emotionally, and then I will just request them that this is for you. Okay, so this course is for you. You no need to study only the course to get the marks. Okay, so you need to learn the things from the course. That's the main motive of give or like attending the course. So marks is okay, so I can restrict the marks, I can be very liberal. So this depends on me. I can make the questions very easy, I can make the questions is difficult. So getting a good grade doesn't mean that you already understand the things, and getting a very bad grade, it also doesn't mean that you haven't understand the things. Okay, so it's all subjective. I believe that all subjective, it depends on the question patterns. Some are lucky, some are unlucky. If the question one is very easy, you could score more. So the basic thing is you ask yourself whether you understand the problem or not. Okay, so that will make the difference in your future career. So that's my motive. Okay, whenever I teach any course, that's my motive. So I just ask the students to understand the thing. Getting marks, getting grades is okay, is subjective. It depends on the question types, it depends on the question patterns, and it also depends on your luck. If your environment is favoring you, of course you can write a good answer. If the environment is not favoring you, you are puzzle or something, then it will affect your results. Okay, so all are subjective. So marks doesn't mean that you are very good. Marks also, bad marks also doesn't mean that you are very bad. Anyway, these are just side talks. Anyway, so any, if I haven't get any comments, so I try to move forward. Okay, you will have the class test. You are listening to me, right?
Yes, doctor.
Okay, okay, thank you.
Yes, doctor.
Okay, so I will move forward because, as I
When we
said,
can get
this is.
our test on
You
paper?
want to ask anything?
When we can get our test on paper?
When you can get
Test on paper?
test one paper. Is not compulsory to return the papers to you. But if you want to see the things, you want to see the papers, you can contact me later on. Okay, I will show you the papers, or I will forward you the papers. But it's not compulsory to show you all the things. You want to learn from the mistakes? Yeah, you can request me, so I will send you the papers. Okay.
We can also see our marks.
Sorry,
The marks.
marks I already shared. Maybe you were absent. Marks I already shared. You contact me later on, okay? Marks I already shared in my last class. I don't know whether you were present or not. Right, everyone? You already know your marks, right? I already showed the marks for question one, question two, and question three. Yeah, yeah. So if you are absent, so that's why you missed out. Others, your friends already know. So if you want to know your marks later on, okay? Not now. Then it will disturb the all others. Okay. So I will continue with numerical, sorry, ordinary differential equation, ODE. So I will again share the things. Okay, so in your e-learning, I think you already have the things. Again, I will show you. I don't know, maybe the internet is a little bit slow here. Okay. So here, is this one is not covered only by this week. I will also continue this topic next week. Okay, so this is ODE IVP. We have the slides example books, but the PDF file I already posted in your WhatsApp group, right? So we have 1, 2, 3, 4 videos. This one is actually this one is very small one, nth order, because I have some corrections when I try to explain something. So I explained it wrongly. So it correct this one in this video. So mainly we have two methods, okay, Euler method and RK method. So I just go to the slides. Hold on 1 minute. Okay. So now, after the differentiation integration, now we are moving towards the ODE, ordinary differential equation. Okay. So you can see this ordinary differential equation. Oh, hold on, I will try to attach the digital. To reopen. So remember that the ODE IVP is very, very important to solve the problems. Even you want to solve the ODE, most of the time we need to solve the differential equation to solve in our research. Okay, so this topic is very important for you. So normally we have the two different types of ODE. One is the ODE, it is ordinary differential equation. One is the initial value problem, like we call this IVP. Okay, so initial value problem. It means in the problem statement, you will get the initial conditions. Initial condition. It means, for an example, at t is equal to 0, your velocity is this much. At t is equal to 0, your displacement is this much. Okay. Another one is BVP, boundary value problem. So boundary value problem, I will discuss this one after this topic. Okay. So boundary value problem is give you the boundary. It means at x is equal to 0, your temperature is this much, T1, and at x is equal to L, your temperature is T2. So it defines the boundary, the edges. Okay. And the next thing that you need to know, what is ODE, ordinary differential equation? You know that we have ODE and we also have PDE, partial differential equation. So ODE is that equation when we have one independent variable. This is a basic, okay? One independent variable. And PDE when we have more than one, that is two and multiple independent variable. That's how we define. We consider d by dx like this, and in case of partial, we call this del x, right? So these things you already know from the mathematics. In this case, we have basically two problems. One is Euler method, another one is Rogge-Kutta method or RK methods. So these are the two problems that you have to study in this course, in this topic. Okay. So main objective to solve the derivative. What kind of derivative? Ordinary differential equation. Okay. We call this derivative equations. This could be first order, this could be second order. So first thing is these kinds of equations. So this is, in this case, the V depends on the T. So I'm going a little bit faster because already the videos are recorded. I will give you just brief idea. Okay. So V depends on the T. It means that your velocity have one independent variable. So this is ODE, no doubt, right? So if someone is asking you to solve the acceleration, so it means that you have to consider the derivative of V with respect to T. It means you need to solve this problem, right? You have to solve this problem. This is another one, ODE. So this one, they say that what is the definition of ordinary differential equation? So one independent variable, and you have, if you have more than two, or more than one actually, two or more, then we call this PDE. So in this case, V depends on the T. On the other hand, we have X, Y, Z. Okay, so this is the PDE. we have lots of equations that we have to solve. For example, Newton's second laws of motion, F is equal to ma acceleration. So this one, this is a ODE. Fourier heat law, this one is the heat transfer, heat flux. This one is also ODE. This is the law of diffusion. This is also ODE. It means like in the physics, lots of equations we have where we need to solve the problem. That the equations are actually ODE, ordinary differential equations. It is very, very important to know this, how to solve it. Okay, next is the order. So order is the highest derivative that you have in your equation. So in this case, the highest derivative that you have is 1 in this case. So it's a first order equation, right? On the other hand, in this case, you have the second order. The highest derivative is 2, right? So it's a second order equation. So it defines the order of equation defines by the highest order term that you have in your equation. So you remember that this one is a spring mass constant. So this is ma. So this is a cx. Sorry, cx dot plus kx should be 0. Anyway, we have the a, so we call this x double dot, right? So we have the second order equation. We can also have a higher order equation. So in this topic, we will not only solve the first order equation, we will also look up how we can solve the higher order equation, second order, third order, fourth order, fifth order. Okay, so there are some ways that we can simplify it and we will get the system of first order equation. Anyway, so that I will talk about it later on. So next is this is the slope estimation. This one maybe I can discuss it maybe later on. Okay, anyway, this is the actually basically the Euler method. Remember that the Euler method is the method that gives us the solution very quickly, but in terms of accuracy is not that much accurate. So when we need to solve any sophisticated problem, we always prefer RK method. Because the Euler method, we have some simplification and it will give you the solution quickly and it's very easy to solve. It's just one line, but it contains a lot of errors. So in terms of accuracy, we don't prefer Euler method, we prefer RK method. On the other hand, if you need fast solution, you are not concerned about the accuracy, we prefer Euler method. Okay, so how we can perform, or what is the equation to solve the Euler method, using the Euler method? This one is directly related with the Taylor expansion. Okay, so it's directly related with the Taylor expansion. So in this case, I can write in this way sorry, hold on. So I can write in this way, right? The Taylor expansion, f of x plus h is equal to f of x plus f prime, right? F prime x and then del x. In this case, yeah, del x. This is the Taylor expansion, right? Taylor series. I am considering the first order term only. It means that f of x plus h is equal to f of x plus f prime x multiplied by, this one is multiplied by del x. So what does it mean? F of x means what? You know the value of y at x. Okay, or if I just change this one, not, and not. So it means that the functional value, it means the value of y at x is equal to x naught. This one, the value of y at x is equal to x naught plus h. It means the future, the prediction. This one is the predicted value. This one is the initial condition. This one we are dealing with the IVP. Try to understand, okay? So IVP, the initial condition should be given to you. It means you know the value of y at your current position or at your current status. It means this one already you know. You want to predict the value for after some step. In this case, this one, instead of writing the h, I can write del x. It means after some time, I want to predict the value. Okay, you know the current status. You want to predict the value after some time. So the value of y after some time will be your current value plus the derivative of the function at your current status. It means you need to consider the derivative of f of x. If you know the f of x, you can also find out the derivative of f of x. And in that derivative expression, you can put the value x is equal to x naught. So you will get the derivative, the differentiated value, the f prime value at x is equal to x naught. So this one also known. This one also known to you. If you know the function, you can get the derivative of the function, and in the function, derivative of the function, you can put the value x is equal to x naught. So you already know this value, and this one is up to you. After how many times you want to predict the motion, or after what is the value of del x, you already know this one. So this one also known. So you can predict the value after some time should be your current value plus the slope of your function at the current status multiplied by step size. Okay, so this is the solution. That this formula is actually nothing but Euler method. Okay, so now here is the thing. For example, the derivative is given. We are dealing with the ODE, right? ODE. So this derivative is actually given to you. It means this part already given to you. Okay, so this part given. Remember, okay, try to match it. So this one also given. Okay, they request you to find out the new value. So it means they request you to find out the value of y. What is the value of y? Okay, and if they ask you what is the value of y is equal to what? And for an example, because this is a function of x and y, it built is maybe okay. I just consider the t. Okay, at time 2 seconds. So your new value, the new value of y will be equal to old value, that is the value of y that should be given. That is the initial condition. For an example, at t is equal to 0, your y is equal to y naught given. This should be given to you. This is the initial value problem. It means this one will be given to you. This is the initial condition. Okay, this is the derivative that also will be given to you. So it means that old value, it means that the current status, old value means in this case current status, this one will be given to you. So the new value will be, your answer will be your current value that is given plus the slope. The slope, the derivative function also already given to you. In that function, you need to substitute the value, okay, at your current condition. In this case, is not matching with the t and xy, but I just want to simplify it. So for an example, your current status is x naught and y naught. So you need to put the value of x naught and y naught. You will get the dy dx multiplied by step size. So how much forward you want. In this case, for an example, in this case, you want to predict the value after 2 seconds. So you put the value, the step size should be 2. Okay, so I will try to solve some problems. So later on you will understand. So mathematically, your new value will be old value plus slope multiplied by step size. That's why you need to remember. So what is going here? So for an example, this is your function. This one, the value of this height is already given, already known to you. You want to predict this one. This one is how much after each step. So according to the formula, this will be this plus, because it's h1, right? Hi. So that is the projected value. So this one, the new value will be this much plus. You need to draw the slope at this point. This is the slope for an example. And you need to consider the slope multiplied by h. That means this part. Okay, so this one is the y, h. This one is the phi. So tan theta is, this should be tan phi multiplied by h. So phi is what? Phi means tan this one, right? This is, if it is theta, this should be theta. This is a slope. Slope means tan theta. So it means in this case, the slope multiplied by h means this part, the green one. So the total will be blue, the initial value, plus this small, the green one. So your resultant will be here, right? But actually you can see that if you draw the vertical line, your value is here. So this is your error. This much distance is the error. So you can see the error is very, very big. So error in one step. So this error can be minimized if we consider h is very small. H is very small, okay. So that's why what we do, for an example, I try to give you the idea. We need to, for example, we need to predict the velocity. Okay, velocity. We need to predict the velocity at somehow, and your dv by dt acceleration is given some function. I'm not expressing the function. You need to find the velocity, but here the velocity is v naught at t is equal to 0. Okay, this one is given. So dv by dt should be given. Remember, the derivative is already given, and the value, this value, the dependent variable v also is given at t is equal to 0. They ask you to calculate what is the value of v after t is equal to 4 seconds. What will be your velocity after 4 seconds? Okay, so minimum requirement, this one already given. Initial condition also given, right? And they ask you to solve it by Euler method. So how we will solve it? Okay, so in this case the step size is 4 seconds, right? So there are two ways to do it. If you consider your step size is maybe step, I can consider h, okay? If you consider your step size is 4 seconds, 4 seconds. So what will be your value? So v at t is equal to 4 will be v at t is equal to 0 plus dv by dt at t is equal to 0 multiplied by h, right, is 4. This is your answer. So the velocity after 4 seconds will be the current velocity plus the derivative that is already given. In the derivative expression, for an example, you have 2t square plus 5. So you need to put t is equal to 0, right? Because you need to consider the current condition. If you put t is equal to 0, your value should be 5. So you will have the value multiplied by 4. So for an example, this one is, if I consider this is 3. So what will be your value? So you should be 3 plus, if t is equal to 0 here in this case, so your value will be 5. Sorry. And 5 multiplied by 4 because you're 4. So this should be 23, right? Just an example. This is one way. But if you consider this 23, your step size is too big. It's too big. So what we do, we don't adopt this one. Okay, we need to consider step. So normally in the problem, they always say that consider the step size 0.5, 1, something like 0.1. So how to do that? So everything is okay. Now I try to solve it. So they say that maybe your h is 1 second. Your h is 1 second, okay? So what we will do, we need to consider the step by step. So after t second, we use the value of t is equal to 0. We want to predict the value of t after 1 second. It means t is equal to 1. So what we will do, so velocity t is equal to 1. Sorry, because your h is 1, should be equal to velocity t is equal to 0, then plus dv by dt at t is equal to 0 multiplied by 1, because your h is 1. So you will get the result, right? You will have the result. So after that, your destination is t is equal to 4, remember. So now you are only one step. You move from t is equal to 0 to t is equal to 1. Then After that, what you have? Where is my cursor? Okay. Okay. So at this point, what we can say? We can say that at t is equal to 1 second, your v is equal to how much? There's some problem. Just hold on. Okay. So here you can say at t is equal to 1, your v is equal to this value, right? Whatever value you get here, your v will be this much. Okay, I just write v t minus 1. Sorry, t is equal to 1. It's not minus, it's so equal, right? So after doing the operation, you already know that now your current state is t is equal to 1, v is equal to vt plus 1. T is equal to 1. It means this value. So now you forget about the past. Now you are here. So now you use this one for next step. So I'm writing here. So your v t is equal to 2. So from using the 0, you already have 1. Now use the 1, you will get the 2. So v is equal to 2 will be, should be equal to v t is equal to 1, that you already calculated here, right? Plus dv by dt, in this case at t is equal to 1. So before you use t is equal to 2, now you need to use t is equal to 1. So in this case, so t is equal to 1 will be 1. So 5 plus 2, it should be 7. Multiplied by 1. Again, still the step size is always same. So now what you get? You already have v is equal to 2. I mean the value of v after 2 seconds should be the value of v after 1 second that you already just calculated one step ahead before. And dv by dt, you just put the value of t is equal to 1 multiplied by 1. So you will get v t is equal to 2. So similar way, after this what you will have? You will have t is equal to 2, your v is equal to v t is equal to 2. So now you use this condition, you predict that t is equal to 3. So that's why we need to move step by step. So we use this one, we predict this, then we use this, we predict this, we use this one and we predict this, and at last we use this, we will predict this. If you do so step by step, not jumping to the final destination, you minimize your step size, okay, and just walk slowly instead of jumping directly to the solution. Then the result that you will get will be very, very accurate, but still not accurate enough if you compare with the Runge-Kutta method, RK method. So we normally ask the students in the question, if you see, we normally give one problem and then ask the student to solve using Euler method and also using Runge-Kutta method. Okay, we normally do like that in the class test. You need to solve same problem using two methods and compare it. Okay, so this is the method that I say is very, very simple. Okay, but if you understand the logic, it should be okay. So let's see the problem. Okay, let's see one problem here. So derivative function already given, as I said, should be given, right? Then what is the next thing you need to know? You need to know the value of y at initial condition. So x is equal to 0, your y is equal to 1, already given, satisfied. Now you are ready to start. Now they ask you to solve this equation. Solve means you need to find out the value of y. Solve means what? You need to find out the value of y. Using Euler method, okay, from x is equal to 0 to x is equal to 4. X is equal to 0 is your current state space. You need to find out the value of x is equal to 4. So they say to find out the value of y from x is equal to 0 to x is equal to 4, considering the step size is 0.5. Okay, so it means 0 value is already given, y is equal to 1. Then what is the value of y at x is equal to 0.5? Then x is equal to 1, then 1.52, 2.53, 3.54. All the steps you need to find out. It's very easy, okay? So you will not get this kinds of problem. It's just straightforward. Again, I'm saying that. So maybe you need to do some simplification. Maybe the equation could be a little bit complex, okay? But the strategy should be same. As I said, explained in my last class, don't afraid of the equation or those things. try to get the information that you need and straightforward starts getting the solution. Okay, so here, as I said before, so you can use the notation if you as whatever you like, but try to simplify it so that anyone can understand. So here they say that y 0.5 means the value of y at x is equal to 0.5. So you can write in this way. You can also write like this way. So it's up to you. So this one should be the value of 0 plus the functional value. In this case, you can see here is a function of x, right? So in this case, you need to just put the value of x is equal to 0, okay, and multiplied by 0.5. The step size is this one. So after x is equal to 0.5, your value of y is this much. So we use this one again. So at this stage, we have x is equal to 0.5 and your y is 5.25. We use this one as again for the next step. So y, this one is actually the true solution. True solution means sometimes you, of course, you need to compare. So we just differentiate because this one is easy, right? Just integrate it. If you integrate, you will get the y value. So they do this the same thing. They try to solve it analytically. Okay, if you understand that x to the power 4 by 4. Okay, so 2 and 4 will be cut down to you x to the power 4 by 2, something like that here. So they solve it analytically and put the value of x is equal to 0.5. So the value, actual value, the true value is this much. And this is the calculated value using Euler method. So the error is how much percent you can see. We can use the absolute error. No need to consider the minus sign. Just focus on that. Okay. We can consider absolute error or relative error. So in this case, I don't know which one they consider. Maybe they consider there is a relative error, but should be then we should not have this minus sign. I don't know why they give this. Maybe just to demonstrate that. So next is this one is again the Euler method. So one should be 0.5, this much and this much. So this one you can see they use the value here plus the function already know, but they put the value x is equal to 0.5 multiplied by 0.5 here. And then again the true solution is this much, so the error is this much. Okay, so by this way, if they solve x is equal to 0, 0.5, 1, 1.5 like this until 4, these are the true values, these are the Euler values. And at the end, when you reach here, the error is how much? Very big. So when your step size is very small, your error is less. When you consider from here to here, is bigger. It means if you forecast very small or closer to the actual value, you will still get reasonable accuracy. But when you want to focus on the large gap, you are here 0, you want to predict 4, even you are using smaller step size, your error is very, very big. So we normally never encourage Euler method to solve any sophisticated problem. But we can do it to get the quick solution. You can see it's very, very easy to solve. Okay, so this one I already explained in the MATLAB part. I'm explaining here. Okay, it's a Hume's method. This one is not considered in our topic. So I will go here, RK method, Runge-Kutta method. Maybe I don't have enough time, so I will try to explain. You better need to watch the videos. I will re-explain this one in the next video. Okay. So just briefly, I want to just clarify a few things. How this one is different than the Euler method. The advantage of the RK method is you can get the accuracy similar like the Taylor series without requiring to calculate the higher order derivative. So we can achieve the same level of accuracy even though we are not considering higher order terms. Okay, and the formula is like this. Okay, don't be afraid of this these kinds of equations, because later on you don't need to derive these things. You need to know the simplified formula. So the main formula is, so the new value will be old value plus, we have instead of the slope, Now we have x, y, and another age multiplied by age. Everything is same. Just you have this part including here. This is not the complete expression, okay? So here the phi is actually a1 k1 plus a2 k2 plus a3 k3. It depends on the points that we consider. And inside this k, we call this recurrence relationship. So each k1, k2, k3, they have some expression. And a1, a2, a3, these are constant. These are coefficients, okay? For different formulas, we have different types of coefficients. So this k1, in this case, is just direct a function. Just a function, right? The function that is given, f of xi, yi. K2 will be f of all our functions, but instead of x, we consider what? Xi plus p1 h. P1 is again one constant coefficient. And comma, and in case of y, we consider yi plus q11 k1 h. So q11 again constant, k1 is this k1, we need to substitute here. These are actually values, okay? When we put the values, these are actually numerical numbers, okay? So we will have k2 will be, you will see function of something, comma something. You need to calculate, maybe for the x coordinate, you have some equations, you have some expressions. You need to do xi plus p1h. But at last, when you do the, when you put the value of xi, py, p1 and h, you will get at last one number, numerical numbers. This one you will get again number. So then you just put the value of x and y in the expression, you will get k2. It's very easy, okay? Not that much difficult. So just you need to know the expressions. K3 will be also like this one, and for the y part we have 3 operations to do, right? Anyway, so normally when we consider the first order, we have the order of Runge-Gupta method. When we consider the first order Runge-Gupta method, n is equal to 1 is nothing but Euler method. Okay, so if you consider n is equal to 1, so we have only phi should be a1 and k1. Okay, just to let you know, when you consider n is equal to 1, you will have this one only. And in this case, a1 should be 1. So this should be k1, right? So k should be f of xi, yi. So you can see that this one is nothing but f of xi, yi. It means this is the same like Euler method. But normally we don't have we never use the first order, we use the second order or fourth order, especially fourth order. Okay, so this is the first order simplified formula. You need to know the just formula, okay? Nobody will ask you to derive this. So the new value will be y1. So as I said, the first order will be a1 and k1, right? And k1 is this one, you already know. And in case of first order, we consider a1 is 1. So this is nothing but Euler method. So as I said, nobody will ask you to use the Runge-Gupta method first order. Second order also probably may be used or may not be used. In case of second order, we will have a1 k1 and a2 k2. I will go to the direct answer, okay? So I will not explain the formulas here. So in case of second order, right? So the things already explained in my video, so I'm just trying to summarize. In case of second order, we have a1 plus a2 is equal to 1. This value is half. This value is half. So you can see that we have 4 unknown, a1, a2, p1, and q11. But we have 3 equations. It is not satisfied, right? So we must have some assumption. Based on that, we will get the result. So that's how we have different form of second order equation. We have different forms. Okay, so first form is this one. This one is Hume's method with a single connector. In this case, we consider a2 is equal to half. This is our assumption. Based on that, we get the formula. Okay, based on that, your formula is this one. Your new value will be y1 plus half k1 plus half K2 multiplied by H, where K1 and K2 is actually function value and K2 will be this one. It means Xi plus H, and in case of Y coordinate, you need to consider Y1 plus K1H. Okay, this is your formula you need to remember. So when you have K1, we utilize it in the Y coordinate, not here on the Y coordinate. We implement it like this. So just I will give you the brief idea about the formula so that when you will watch my video, you will understand. Next one is a midpoint form. In that case, we consider A2 is equal to 1. Why we consider this one? Because I said that 4 unknowns, 3 equations. So we need to consider some assumption. So if you consider A2 is equal to 1, we consider midpoint formula. So formula is like this. New value will be old value plus K2H. There is no K1. But to calculate the K2, you need K1. Okay. Next, this one is the Ralston formula. When we consider 2/3, so this is the method. This is the formula. So in order to get the value, you need K1 and K2. And K1 and K2, you need to calculate separately, put it there, and then you will get the result. And the last one, maybe don't have enough time. So I will explain the things again, the RK method next week. But this week we will have the quiz, okay? Based on the integrations, numerical integration. So because the time is up, so I want to share the attendance again. Anyone left behind?